the Algebra 1 Summer School Unit 6 Lesson 2 video, Solve by Graphing. So this is our Solving Quadratics unit. The first lesson of this unit was how to solve quadratics using the method of factoring. Today we're going to look at the graphs of quadratics, what the graphs look like, and then also what do the graphs tell us about the solutions of the quadratic. Before we start, we need to talk a little bit about some vocabulary. It says at the top that quadratic functions can be written as ax squared plus bx plus c. A cannot be 0, so the first term is not 0, otherwise it's not a quadratic function. That format is called the standard form of a quadratic function. The shape of a graph, which we can see down here in the picture of a quadratic function, is called a parabola. Parabolas are symmetric about a line called the axis of symmetry. The axis of symmetry is represented by this red dotted line on the parabola shown below. It's usually, we don't normally draw it in, it's an invisible line, but it's a line that shows that the graph could be folded over on itself and it's going to be exactly the same on both sides of that axis. The axis of symmetry intersects or crosses the parabola at a point. That point is called the vertex. Sometimes we also call that vertex the turning point of the parabola, right? Because that's where the graph changes direction, it turns. Right? So we can see that there's a parabola here. That's a graph of a quadratic. It has a vertex and an axis of symmetry. Parabolas can either open up, look like a U, or open upside down. When the parabolas open up, that means that our equation in standard form, ax squared plus bx plus c, the a, the first term, or we can say the leading coefficient, I'll write it that way, the leading coefficient is positive. So our graph is going to open up, and the vertex is going to be a minimum. That's the lowest point on the graph. We learned about that in our functions unit. When the leading coefficient is negative, our parabola opens upside down, and it has a very highest point called a maximum. So let's look at these next 3 examples really quickly and just determine by looking at their leading coefficient whether those are maximums or minimums. For the first one here, a is the number in front of x squared, so that's -2. A is negative, which means my parabola is going to open upside down, which gives me a vertex that's a maximum. For the second one, 2x squared minus 4x minus 1. The leading coefficient is positive. It's +2, which means positive is opening up, and my vertex is a minimum. Lastly, -x squared plus 4x minus 3. The number in front of x squared is -1. A is negative, so we open down, and my graph has a maximum value. Now there's one more features of a parabola we're going to look at, and then we're going to graph them. Domain and range. We talked earlier in the functions unit that the domain in general of a function are the set of x values, right? Domain on a graph works from left to right. When we have a parabola, parabolas always have arrows on them. So the domain, because there's arrows, it goes out forever to the left and forever to the right. So we say the domain is always all real numbers. We'll see that once we do some examples. Now, for example, it says here, if a is greater than 0, that means the parabola opens up like I drew, then the range is something. Well, remember, the range is the set of y values that the function has. And when you look at this set, we start from bottom to top. So when I look at the range here, my graph definitely has a bottom. It has a very lowest point. All the y values are going to be greater than or equal to the minimum value of the function. Every other part of my graph is higher than the minimum. Now, if my graph is opening down because the leading coefficient is negative, the range is lower. All the y's are less than the maximum. It has a maximum value. The whole rest of the graph is lower than it. Right, that's a little bit tricky. It's going to be a little bit easier once we look at actual graphs on the next page of your notes. All right, graphing quadratic functions. When we graph a quadratic function, a big thing that we're looking for are the x-intercepts of the parabola. All right, those are the solutions to the quadratics. Now, that's exactly what we were doing in the last lesson when we did solve by factoring. We were trying to find the solutions. Well, those solutions on the graph just happen to be the x-intercepts. Now, there are other words that we use to describe the solutions. We can also call them the roots of the parabola or the zeros of the parabola. All right, zeros, roots, solutions, and x-intercepts, they are all the same thing. So what we need to do is you need to get out a graphing calculator. You can't graph a quadratic without a graphing calculator. We're going to graph x squared plus 4x minus 5 using our calculator. So what you're going to do is you're going to pull up your calculator and you're going to go to the y equals. When we graph, we have to make sure that everything is cleared out. And we're going to graph x squared plus 4x plus 5. Now, I can hit graph, and this is going to show me a picture. Oh, and this is a good rule here. If your grid does not look like the normal 10 by 10 grid, you're going to hit zoom 6. That takes you back to your standard grid, which I think I must have typed. Oh, it should have been a y equals negative 5 here. So plus 4x minus 5. That'll give me the graph that I know I want. There we go. All right, now if you forget, the way you get to the table so you can plot the points is I go to second table here. These are the points that I'm going to start plotting. Now you need to go ahead and kind of figure out which points are going to fit on your grid. It looks here that the negative 7, 16 isn't going to fit, but anything from negative 6 to x equals 2, those should all fit on my paper. So I want you to take a moment. You can pause the video if you do not have a calculator, but you should, and take this table of values and copy it onto your paper. I'm going to do the same on my grid, and then we'll join back together. All right, once you've made your quadratic, or your parabola, it should look something like this. Mine isn't exactly perfect in tracing, but it's close. You can tell it's a parabola. From this graph, we're going to identify all the information that's in the box. The vertex is where my graph turns direction. On this graph, that appears to be at negative 2, negative 9. We're going to write that point as an ordered pair. Now, the equation of the axis of symmetry can be tough. This is the line that goes right through the vertex, right down the middle of the parabola. Now, that's a vertical line, and vertical lines cut through the x-axis, so they have an equation x equals. And the x value it equals is where it cuts through the axis at negative 2. So that's the equation of the axis of symmetry. Notice that that negative 2 is the same value as the x value of the vertex because it cuts through that vertex. When I look at my graph, this vertex is the lowest point on the graph. That's called a minimum. Also, when I look at the graph, I have a y-intercept. That's where I cross the y-axis. That seems to happen at 0, negative 5, not positive 5. Now, here's one thing you might notice too, or you might remember from class. This negative 5 for the y-intercept is the constant in the equation. That's your y-intercept. Now, the x-intercepts are where we cross the x-axis. That x-intercept looks like it happens at negative 4 and positive 1. So the point negative 4, 0 and 1, 0 are your x-intercepts. Now let's talk about domain and range. Domain is left to right. So first I'm going to look at the arrows in my graph. It looks like it's going out forever to the left and the right. So we say that our domain here is all real numbers. Remember we said just on the previous page of our notes that the domain is always going to be all real numbers for a parabola. Now the range is the lowest value to the highest value. So when I look on my graph, I have a minimum. That minimum, all the rest of the parabola is higher than it. So all the y values on my graph are greater than or equal to the y value of -9. That's the y value from the vertex. All right, let's do a couple more of these so we get into our head how we find all this information from the graph. Number 5, I'm going to graph -x² minus 6x plus 7. Just like the last problem, I need to go to my graphing calculator, go back to the y equals, and type in the equation. -x² minus 6x plus 7. Hitting graph allows me to find the picture that I'm going to make. Let me double check I graphed that right. -x² minus 6x plus 7, that's it. And hit the graph, it's going to look like this. Now I need to find the values I can put on my table, or on my picture. So I'm going to go second table, and that looks to be about right. So I want you to take a couple minutes. I want you to copy the information from the table and plot that on your grid. I'm going to do the same. All right, now that we've all graphed our parabola, let's identify the information in the box to the left. The vertex, the turning point of our parabola here, appears to be at -3, +16. Now the equation of the axis of symmetry is the line that cuts right down the middle of this parabola. That is always equal to the x-coordinate, that equation of the vertex. Now my graph has a maximum this time because that is the highest point that the graph has. The y-intercept is where you cross the y-axis, which is at 0, 7 this time. Again, notice that the 7 is the constant on the end of the standard form of the quadratic. The x-intercepts were across the x-axis. Those are at -7 and +1. Because my graph goes on forever to the left and the right, my domain is all real numbers. And my range always deals with y values. Now here, this time, my y values max out at 16, and everything's lower than 16. So I'm going to write the inequality y is less than or equal to 16. All right, one more. This is going to be an OST style question before we get to practice. So we have a function shown, x² plus 2x minus 3. It says use the add point tool to show the x-intercepts and the maximum or minimum. So you don't even have to graph the entire equation this time. This would be a computerized question where you use what they call the add point tool to just add points to your graph. So we're going to add the points of the x-intercepts and the max or the min. So what I would do to start this is to graph this equation on my calculator. So when I pull out my calculator, I'm going to type in x² plus 2x minus 3. When I hit graph, I should be able to see a nice quadratic. Now from my graph, I can estimate where the x-intercepts and the vertex are. I can also get that from the table. The table shows me the x-intercepts. That's when the y value is 0. So I can look here and find that, oh, my x-intercepts are at -3, 0, and 1, 0. So let's put that on our paper now. -3, 0, and 1, 0. So all we have to do is put the points on. We don't even have to graph the function. And then I'm going to put the maximum or the minimum on this graph. Well, looking at my picture, my graph has a minimum. And I want to know where this minimum value is, right down here. Your calculator, you can get this from the table, but your calculator has a tool that will help you find the minimum. What you do is you hit the second button, then trace. I'm going to go down to number 3, which says minimum. Now you should see a blinking cursor. That blinking cursor, right on the bottom down here, it says left bound. I'm going to take that cursor to the left, you should see it moving, of my vertex. Once I'm there, I click enter. Now it says right bound on the bottom. So I take my cursor a little bit to the right. Once I'm there, I hit enter again, and then you see the word guess, hit enter, and you get that the minimum is at -1, -4. They give you that point. So I can go ahead back to my paper, I can plot the point -1, -4, and that's all that they asked for in that question. All right, go ahead and try the practice that's attached to the notes and the second practice file. If you have questions, look at the answer keys posted on Canvas or come into office hours and ask your instructor.